Welcome back to Azure Terraformer. On the previous episode, we analyzed some code, and now we're going to dig into that code and do our code review. So we've kind of gotten our bearings, looked at some of the structural components of the code, drew this diagram, which we can see we identified there's a multi-tenant aspect going on here, where we have n number of client deployments that are using an Azure web app that's deploying to an Azure app service plan, which exists within this shared deployment down here. And we noticed that there's a pattern where the root modules, there's a shared root module, and each client has its own root module. Each client is using this main module as a place for the reusable bits of each client deployment. And then the reusable module is making a Terraform state reference of the shared deployment to reference the shared infrastructure. And then this root module for the shared infrastructure is just using a module that encapsulates the entire deployment. So we'll dig into the code there a little bit. This is a very common method for structuring root modules, and basically trying to keep the root module as lean and thin as possible, and putting your entire deployment inside basically a deployment module, which I think is it makes sense, and it definitely is future-proof with minimal over-engineering, because you essentially have a module that you could eventually stamp out multiple environments in your root module. And so your root module is already set up in such a way that you can start stamping out copies of your environment. So this approach is ideal for multi-region scenarios where you want to stamp out multiple copies of your environment and then load balance across them. And then you put some sort of a global load balancer in the root module to distribute traffic across these, independent deployments in each of the regions. So, so that's what we're looking at. We're going to dig into the code and see what we like about the code and some of the coding practices, code health, code quality, and some of the design in terms of the boundaries of the modules and things like that. So without further ado, let's get going. Okay, so looking at the client, we got the main module. We have, again, I've brought this up in previous talks. I'm not a huge fan of the backend state being stored in this way. I would question, why do we even have a different state file for each client? The nature of this multi-tenant solution, could be the answer, and I'm ignorant to that. What my friendly internet stranger told me is like what I shared with you. That's all. So that's all I know. I don't know if there's some reason why the operator layer of this solution is so segmented, but I would say, unless there's a really good reason why you need to segment your operator layer for your tenants, I wouldn't do it. Because especially if you're a small company, or even a big company, you don't want to waste money unnecessarily having separation of, siloed tenant boundaries, at the operation layer. You want to make it super easy for your support staff to manage the environments across all tenants. And so creating boundaries for the state file, these are artificial boundaries. It's the same solution, it's the same code. Why do we need different state file? And it also kind of leads down this path of forking the environments to make unique pet type environments for each client. And I'll tell you what, that's the biggest no-no in multi-tenant system design, and it is the pathway to darkness. Let me tell you, that is the road to Mordor. As soon as you fork. You're like, and it starts small, right? It's like, well, let's just make the client number 2 wants this like little change. Let's just do it for him. And by the way, the salesperson, tells us they brought us a big bag of money. So like, we can't turn down their money. That's how it always happens. Some client is just like, hey, you don't have this feature. And then the product team is like, yeah, it's on the backlog. And the client's like, well, I need it like yesterday. And they're like, well, we'll bump it up in priority. We'll get to it. And the client's like, nope, you're either going to lose me as a customer or here's a big bag of cash. What do you think the product team's going to do? The product team is going to bubble it up to executive leadership. Executive leadership's going to be like, lose a big customer, lose 33% of our customers, or take a big pile of cash. I wonder, right? So this is the road to technical debt. I'm not saying like it's, you make your own business decisions, right? But like, be aware that this is a common like anti-pattern that leads to long-term pain, which is then rectified by usually paying like consultants like me in my former life to come in and solve your problems for you, because it becomes so overwhelming you can't like add customer 11, right? Because you're bleeding so badly with just the 10 customers that you have. So anyways, I would really question, like, do you need to have separate state files per customer? I would only do that if you were going to have an absolutely separate support team per customer. Like, let's say your customers, client 1, client 2, they're just huge customers. And they bring in like $100 million or $10 million of revenue a year to your business. You could probably handle a 24/7 support staff for each one of those clients. Go for it. But if you're trying to build like a multi-tenant SaaS solution where like you're going to have hundreds of customers and you're going to be running razor thin margins, probably not a good plan, right? You probably want to have all of your tenants like deployed using the same state, and do it as efficiently and consistently as possible. And using this folder-based deployment approach, where we have a folder for each client, right off the bat, you're hard coding, each client in here, and it's getting absolute special treatment, right? And so you're already pushing yourself down this path of treating customers as pets, treating clients as pets. And in a multi-tenant solution, you do not want to treat your tenants as pets, because then you're going to be hurting cats. So that's what I'll say there. And then what would happen is what I'd probably do is I'd probably collapse this client tenant configuration into like an array of objects, or some way of inputting this on a per tenant basis. And I'd probably try and eliminate as much as possible the number of variations from one customer to another, so that like the surface area for per tenant customizations goes down big time. And if I think one right off the bat, I probably, like, if I use the same access, if I use the same key vault, the access key probably goes away, right? If I use like a SKU rather than like all of these different properties being set for the database info, silver, gold, platinum, whatever, bronze, SKU, then, it becomes much easier to control like what scale your customer's at. And so then you don't have to have like 20 different parameters that could vary independently for each tenant. You've got like 4 or 3, right? I could understand like there might be like different region. You might want to put them in a different region. You know, makes sense to me. But again, different region is also going to impact, you know, what your shared infrastructure looks like. Yeah. So speaking of shared infrastructure, let's go look at that. So we have an app service plan, which has a specific location. We've got one of those, right? So right off the bat, we are allowing customers to change the location that they're in. They just both happen to be North Central US. But the way we've structured our code is we're allowing them to have the option of, like, we're literally hard coding North Central US in here, which means, like, if I wanted client 3 not to be in North Central US, I'm kind of indicating to the people that are maintaining this environment that, like, yeah, you can change the location from North Central US to South Central US, to West US, to East US. But that's not going to work because main is tied to this shared module, and the shared module is going to deploy to one place, right? So again, this comes back to that tight coupling, a couple issues, the tight coupling with the shared, you know, deployment, you know, this app service plan and the shared module appears to be designed for single location targeting, whereas we have a strategy with the multi-tenancy where we are enabling multiple location targeting, which they're incompatible currently. I would have to modify my shared module to pass in n number of locations, and then I would have to stamp out the shared module across n number of locations: North Central US, West US, East US, wherever I wanted to place customers, tenants, clients, whatever you call them. And then each client environment, I would have to not just, you know, specify which location it's going to be in, which would absolutely be required, but I'd have to tell it which shared environment to go grab the stuff from. Now I could do that through, you know, naming conventions, or I could do that through, you know, the state file. I could have different state files for the different locations. I could use data sources, which would probably be the approach that I would opt for. Is I'd have a data source for picking the app service plan that I wanted to deploy to, picking the SQL server in the right region that I wanted to deploy to, etc. Right? So I think the multi-region strategy here really needs to be revamped, because the way that it seems like that design has influenced, the flexibility of that in the design has influenced how the tenant modules are structured, but they are not ready for that in the shared infrastructure at all. Now, in some ways they could be, because shared infrastructure is a module in and of itself, and that takes a location, right? But the way they are currently coupling the shared deployment, right? We got one North Central, boom, that's it. And that goes into the shared TF state file. And guess what? Main is just grab bagging the shared TF state file, right? Again, when you use a shared state, you are tightly coupling those things, big time. And so if we go stamp out, you know, North Central, West US, East US, you know, now like this has got to be named differently, and the state file, shared state file, gets bigger and bigger and bigger. Whereas I could just poke, like, what do I actually need? What do I actually need in my main here? What am I using from state? Let's look. No, that didn't work at all. Oh, good Lord. Can I not copy? Okay, there we go. So we have 5 references. Okay, so number 1, the key. So we are adding, so this Key Vault module, if you remember, the Key Vault module is responsible for creating secrets for our database. Okay, so each tenant is going to have a different database username and password. Okay. Makes sense. It's going to be stored in a different key vault. Yeah, and I mean, so how you would do this without using Terraform remote state is if there's going to be shared secrets across tenants, you'd probably just create a key vault, put in the shared database servers, username and password, and then use data sources to the key vault secrets just to grab the secrets that you want. I've done this on my channel many times. I believe using the SSH key secret. Yeah. So I poke a hole and I just get the SSH key secret, right? And that's it. And then I set that up there, right? What else do we have? So 2 of the 5 remote state use references are just the database secret, right? Next is a VNet ID. Easy peasy data source to a virtual network. Use a naming convention to pick the right virtual network. Get a data reference to it, and there you go. What else? The SQL Server ID, same, right? And that's it, folks. We got, actually, I can count them on my fingers. If you get rid of the Key Vault stuff, because we have alternative solutions to do that, right? You got 2 things. And yet we're importing the entire Terraform state for the shared deployment just to access 2 things. I wouldn't do it. I would just set up 2 data sources. There you go. There's no tight coupling. It's like, okay, I need my SQL Server and I need my virtual network. That's it. Now, why this is great, why this is better, great's a funny word, is in the future, if I want to change how how my data source grabs the right VNet, right? Let's say I want to expand my shared infrastructure to be multi-region, right? I build in a naming convention to my VNet and my SQL servers, right? And now when I go use my data source to go get the correct SQL servers, the correct VNet, boom, depending on where my customer, what region my customer's in, I can go grab the correct region, the correct SQL server and the correct VNet in the correct region, just using the data source, right? I don't have to go monkey around with the state file and go get the right, state object resource thing that was deployed there, right? I can just, I'm drawing dependency on 2 things. 1, the SQL Server. 2, the VNet. That's it. If those things don't exist, I'm pretty much shit out of luck anyway. But drawing dependency on the Terraform deployment, I'm not a fan. And that's all I'm going to say on the subject. Okay. So what else do we have here? So this pretty much sums it up, in terms of the main module. It looks like he's using this get my IP address, thing, which gets your public IP address. Not super scalable. Works for kind of lone wolf operations, but I would highly recommend, if you're going to use a pipelining tool or something like that, or if you're going to have a number of administrators, you may want to rethink your network access strategy for one, right? Using, point to site, VPN to allow your administrators to connect, or site to site if you have a corporate office, something like that. That'll allow your operators to access it. And if you want to have a pipelining tool, you probably want to pass in an agent IP variable and do this lookup outside of Terraform. That would be my suggestion. I'm not a huge fan of this is a very common way to look up the IP address using the data resource. But when you're using a pipelining tool, I kind of like, grabbing the IP address outside, passing it in as an input variable. That way it's well known to Terraform, hey, this is the public IP address of the agent running Terraform. And it is different than potentially a collection of IP addresses for known good whitelisted network locations, whatever it may be. Okay. Yeah. So that's it. I would like, just, this is kind of a nit, but if you've got like things like this Azure client config that are highly reusable, I would probably put that up somewhere at the top, just so it doesn't get lost in the crowd, so to speak. I would also consider reorganizing this file, like moving the provider, stuff into a versions.tf. Again, when you go to main, you don't need, you're looking for the keystone stuff. You're not looking for, the provider, right? The provider stuff is just like plumbing, right? It's like, well, what version of, Terraform are you using? Nah, is that really what's main? Is that really what like just screams main for your solution? Probably not, right? To me, the things that scream main are the resource group, right? And, these other things could probably be carved up, or there's a small enough number of them that they could just be thrown in there. Okay. So, yeah, but I would definitely carve out, the provider stuff into its own file. If you're gonna choose to use the strategy of state import, I might put that in its own file, just to like throw the flag out there. It's kind of like a yellow flag thing, like, hey, this is important, it has its own file, right? Don't miss it. Like, it has its own file, go look in that file. So you might want to have, I don't know, like state.tf or something like that, where you put in like a state import, and it's like, bam, this is what I'm doing here. This is another one of those things you do not want it to get like lost in the crowd. Okay, so that's it with the main module. Not a lot in these client and shared, these actual root modules. So let's go look at here. So so this is where the web app is happening. So we're actually deploying a web app and an access policy. Oh, that's interesting. So where does that must get referenced in the app service? Did I misspell that? Maybe that's not implemented yet. Yeah, that's probably coming. But so this is just deploying. So the way app service works is you have an app service plan, which is kind of like your shared infrastructure, and then you have a web app or a function app or whatever, different apps that are then deployed to that plan. And so you'll always see a service plan, where it's linking to that shared infrastructure resource. And so this becomes like kind of a the quintessential parent-child. The app service plan is the parent. The child is all these web apps that get deployed to it. There's some good things here. I like this stuff, FTPS. There's a lot of security things that unfortunately are not defaulted to be good. So I would definitely consider running Azure policy. I checked this particular user profile on GitHub, and it looks like they're doing some stuff with Azure policy. So that's good. I would definitely pick like an Azure policy, run it against your app service, deployments here, and see what shakes out, because I don't know if it's an app service thing or Terraform thing, but they are not secured by default. And so definitely run that thing through Security Center and Azure policy to see like what the badness is here. And we got app settings here. That's cool. We are using, so I would say we're not using key vault references for the app settings. That would be one suggestion. I'll probably have to do a video on that, because it's kind of weird. But basically, rather than because right here, this is going to be a string that has a password in it. And if you have access in the Azure portal, like to this app service web app, you'll be able to go and peek at this password. And you probably don't want that to happen, especially if you're going through the trouble of saving it to Key Vault. So there is a Key Vault secret notation where you can reference a Key Vault secret and not actually save the secret value into the app settings of the app service. So I would definitely recommend looking at that and fixing that. You will need to have an identity on this thing that has an access policy to the Key Vault. That's the catch, right? Is so whatever identity this web app runs under, it's going to have a corresponding Key Vault access policy to allow the Azure App Service to go out to Key Vault, access that Key Vault and that Key Vault secret, and then bring that value into the app setting. So it's kind of like a runtime thing that makes it happen. So just be aware of that. Again, client config. Don't let it get lost in the crowd. I like how your random string suffix is at the top. I don't like building in random strings into reusable modules. I like to extract that out to the consuming module, right? So who's going to call this module called app service? I want the caller of the module to be as responsible for the naming of the resources in this module as much as possible, which is why I very often would just pass in a name, like a variable called name. And then that name is then used everywhere, right? And then all of this logic about using a random string and using the client name and stuff like that, that's all the responsibility of the person calling this reusable module. Because frankly, this as a reusable module, you may want to use this module like where there is no concept of client name. Like what the hell is client name, right? So that may be something you want to think about. This module could be just used for also app settings. You may want to consider passing in like a map of app settings instead of passing in all these things, right? That would make this module a little bit more reusable. And then it looks like we are creating a Key Vault access policy using the system assigned identity of this web app. But what's weird is we're not actually using the Key Vault, to plug in these values. So almost there. This is like 90% of the way there. You just need to use that like string notation to get those secrets in there. Okay. I'm good with this stuff. This is what I call a convenience output parameter. Big fan. I do that. That's good stuff. Very diligent on your descriptions. I like that. We've got, an environment flag here. That's interesting. I tend to have like an application name and environment name, but only in the root module. The reusable modules, like I said, I have a generic name that I pass in because I want the name of that thing to be responsible for the by the calling module. This looks like a wrapper module. This module doesn't add a tremendous amount of value. I would probably just get rid of this module. It's really doing nothing if you think about it, other than like setting application type to other and then setting this weird naming convention. That's it. It adds no value. Key Vault, again, we got embedded rando strings. Not a big fan of that. I like the naming conventions, but then the name of the actual thing should be the responsibility of the calling module. We're a little bit better with the client config stuff in there. What happened here? Oh, my iPad just quit. I think these network things are good. What I would recommend is if you're going to create a reusable module and you're going to go through the trouble to pass in a single subnet ID, just make this variable an array, and rather than like hamstring yourself inside the reusable module, pass in, like, have the calling module construct a single item array and pass it in, right? Same thing with IP rules, right? Don't build that into the reusable module. Extract that out to the calling module and do it there. Role definition name, you're hard coding some pretty fancy strings in here. I'm not a big fan of that. For each, I usually use count when it's deterministic, but I know people get on my case about using you should use for each here. Count's terrible. I don't know. I prefer count when it's deterministic, because when you use for each, it becomes not deterministic, and Terraform will basically say, no, we don't know what the outcome of this thing is going to be until it's done. Whereas if you use count, it will know, because you know ahead of time how many of those things are going to be there. I don't know. The debate for that rages on. So here we got, Wally, come here, Wally. Wally's down here licking my hand. Okay. You gonna help me do my code review? Yeah. Okay. We got a couple of key vault secrets here. Again, I probably wouldn't put a key vault secret into the same module that deploys my key vault, because again, you're kind of hard coding the design. The secrets are the data, whereas the key vault is the database. Yeah. So you probably want to have more flexibility about the data in the database, the secrets in the key vault, than you would want to have about the key vault itself, right? Hopefully that kind of makes sense. SQL DB. So watch out, because this resource has changed over the years. I do not like this. Do not like this at all. So this is a can versus should thing. I know you can take a resource ID and extract the resource group name out of it, and I know you can extract the resource name, which is what we're doing here. We're taking the full resource ID of the SQL server, and we're using string manipulation to split it and grab a specific index out of that resource array. This is number one. It's really difficult to read, right? I understand what's going on here. Maybe you understand what's going on here. The original author of this code understands what's going on here. But again, writing code is not like a competition to prove how smart you are. It's a competition about how easy you can make the life of your future maintainer, right? It should be about, will the person that's maintaining this code, when I'm long gone and retired on a beach somewhere sipping pina coladas, will they curse my name? And I would argue, if you do this, you're going to have a lot of people cursing your name. Like, what are you doing, man? Like, this is nasty. Don't do this, okay? I know Azure is the biggest GUID generator on the planet, but please don't do this. If you need a resource group name and you need the name of your SQL server, pass that in as variables, and just do the hard work of getting a data source, grabbing that sucker, and passing in the values that you need. You know what I mean? There's absolutely no reason why you have to do this. But it is, I'm glad this did come up, because because the Azure RM provider is a piece of open source software, it is rather common to have inconsistencies in terms of different resources wanting, different values. Sometimes they want a resource ID. Sometimes they want a name, and that can be pretty frustrating. But I would say is when you're writing a root module, you are the what is that? You are the anti-corruption layer, right? So you can make the adapter logic to smoothly flow between the components, right? Even if the Azure RM provider sometimes fights against you. So in this case, and this is a perfect example. Look at this. The virtual network rule wants the server ID, which is probably why he passed that in from the get-go, right? But look at this. Like, that's funny. So he's actually passing in the SQL Server ID. He's looking up the SQL Server, and then he's using the variable for the data source that he actually just looked up. Whereas, like, he could have just like said, okay, I'm just going to take this thing and I'm going to say bada bing, and then what is it? Shared. Also, don't use hyphens in object reference names. Where to go? Yeah, you can just do this, right? Like, we already looked this thing up, right? And so basically, you got to ask yourself, why did we pass in the ID only to look up, the name and the resource group? That seems kind of silly to me. Honestly, I'm kind of curious where this data source is even going to be used. Data dot. Look at that. So we're outputting from the data source, right? So I could right off the bat just change this from SQL Server ID, to SQL Server, resource group name. And I could change this to SQL Server, what the heck is it, name, right? And then I could make my life so much easier just by going like this, var dot la la la, and then var dot la, and there you go. So right off the bat, like, I just made this much more readable, right? Now, you're like, Mark, this is too many variable inputs. It's too inefficient. Okay, this is also something I like. SQL Server, okay. Type equals object. I do not like using overly complex or nested object types, so don't even judge me right now, okay? But this is going to be super easy, right? We're going to have a name, and we're going to have a resource group. I could call it resource group, or I could call it resource group name. As long as I know what it is, and then here we go. So then I'm just going to say dot resource group dot name, and I'm good to go, right? So now I have a single variable called SQL Server, which has the stuff that I need. And we're already passing in SQL Server name. Oh, no, I made those variables. So there we go. So we got a single SQL Server there. We're passing that stuff in. Let's see where the SQL Server is even passed in. So is this our SQL DB? Yeah. So right off the bat, we got our SQL Server. We're getting our shared state. It's from this SQL Server. Oh, it's an output. So literally, they would just have. This is why you don't use shared state, because now you're totally tightly coupling to the outputs of that thing. Don't like it, don't do it. Just use a data source and look up the SQL Server, and then just pump in create a, this is no longer going to be ID. We're going to construct an object here, and the object is going to have a name equals data dot, I don't know what SQL Server, I don't know what the type is, right? Dot name, and you're going to have a resource group, and it's going to come off of like some SQL Server thing, right? And I mean, look at this. Like, it would complete. And honestly, like, if we could even get rid of this thing, like this data source could go. Okay, and I could put the data source here. Okay, now I'm looking up my SQL Server, right? And I put in the resource group name here, and I put in the name here, because I mean, it's essentially coming from the state file. And here's why you don't put here's why you don't put hyphens in names. If I want to quickly access this reference object, I can't. I can't double click it. I have to go like this and copy pasta. However, if you put underscores, okay, boom. I'm a simple creature. I know. I'm a very simple creature, but the ability to double click the object reference, I can't get over it. I have to do that. So anyways, I've got this thing, and I'm going to get rid of the hyphen, and I'm going to get rid of the hyphen, and we're going to have a resource group name on there, and there we go. So like I got rid of the data reference. So I don't need that here, right? Now I just have my object, my variable that I'm passing in here, right? And now I just need the ID, right? So the only thing, and actually that's really interesting. Like the only reason why we're doing this is to get the name, right? We need to get the name out of the SQL Server to generate this thing. I wouldn't do this. This seems like unnecessary complexity to do that. And so honestly, I'm going to backtrack because the whole like SQL Server like data reference like threw me off. I'm just gonna actually pass in the SQL Server ID now. Okay, and I'm gonna get rid of all this stuff. Okay, because we don't need that, right? I mean, we just need this. So if you get rid of this thing or move this outside of here, like or move it up to where you're doing this, like you maybe like you can generate this database URL somewhere else, right? Why does it have to be in here? I mean, I guess it could be, but like you just restructure this to be much more simple, right? Yeah. So, and we're back to SQL Server ID, and we're back to SQL Server ID. So all we need is a SQL Server ID. That's it. Yeah. So I think that's a lot better. Storage account rule. Again, the same thing. Like move these array. Like don't force a single item array. Again, we're doing the element lookup, so some of this is kind of repetitive. So that's it for this code base. Really appreciate you sharing your code, putting yourself out there like that. Takes a lot of guts, and I hope you take this review to heart, friendly internet stranger, and don't hate me so much for it. I'm doing this out of love. And if you disagree, let me know. I'd love to hear. And audience, like in general, if you disagree with anything I said, let me know. I'd love to hear different perspectives on things. But these are some of the things that I found and kind of how I would change things. Overall, I think the multi-tenancy should be kind of relooked at. Like, what is that really critical? The physical isolation between the operator layer, I think it adds silos and complexity to the day in the life of the business as usual kind of system administrators unnecessarily, I think, unless there's a big requirement there for that, which you would really need to justify, why that's there. And then I think cleaning up the dependencies between just importing state and actually using data sources. I think you should consider that, because really when we looked at it, there's not a whole lot of dependencies there. So it'd be pretty easy to just like make a very small contract between the two environments, the shared infrastructure and the client environments, and just grab what you need, rather than importing the whole state file and then tightly coupling everything together. So yeah, So this was fun. First time reviewing some Azure Terraform code on the Azure Terraformer. So that's a huge milestone for us. Hopefully I get to see more. Hopefully you guys like these code reviews, and keep them coming. I'm totally dependent on friendly internet strangers that are willing to let me look over their code, give them some ideas, give them some pointers, and give them my opinion. That's all it is, my opinion, on their code and their architecture. So until next time, this is the Azure Terraformer signing off.